Welcome to the AWS Summit in London. We live in such really exciting times, right? We saw that generative AI has moved from the lab to the real world, shaping the way we work and live. And the true game changer was actually your capacity to make the off-the-shelf models your own models. When you fine-tune those models so that they can understand your customers, your business, your products, that's when you use AI as a true competitive advantage. My name is Miguel Cristino. I work as a senior go-to-market specialist at AWS. Today, I'm joined by Sam Sanders, who is a senior solutions architect, and also by Felix Lohman, who is a director of data science at Mimecast. For the next 45 minutes, first, we'll go through how SageMaker AI can actually help you fine-tuning. Then we'll see a demo, and we will have a use case from our customer, Mimecast. Okay, so first I would like to start with a question, a quick raise of hands. How many of you have experience with fine-tuning? Okay, good. A lot of hands raised. Thank you so much. So potentially you'll relate. You started with off-the-shelf models. You tested different iterations. You reached a moment in which you reached the limits of the models in terms of price or performance. So it became more or less obvious that you needed to fine-tune. There are three major reasons why our customers are fine-tuning. The first one is to increase domain accuracy. So you want to make the model more relevant to your specific industry. Let's imagine you work in legal. You add jargon of legal to the model so that it first starts predicting the next token based on a new data set that was not used to train the original public available model. Then a second reason is decreased costs. So you did a proof of concept. It was great, but then when you wanted to scale to production, you actually understood it would be prohibitive in terms of costs. So what you do is that you fine-tune a smaller model that requires less compute so that you can actually make it economically viable and have a positive return on investment. And then the third reason is to improve performance, like, for example, latency or throughput. Today we have Mimecast here that will show you how they fine-tune the model to be able to, one, analyze faster emails, and two, analyze more emails per minute. Because their use case is to try to detect harmful emails. So by fine-tuning a model, they were able to increase performance in terms of throughput and latency. If you resonate with one of these reasons, probably is a good moment for you to fine-tune, but also you need to ask yourself if you are ready actually to fine-tune. The first thing that you need to have is a unique, differentiated data set that I'm almost sure that you have, right? Because you have information that is quite specific to your business, like, for example, customer usage information, or in the case of Mimecast, billions of emails to train the model. And then second, you need a defined success criteria. So you know precisely where you are walking towards. You know when you are ready to production. In the case we'll see today, they knew they wanted to detect more harmful emails. So they knew the moment in which the fine-tuned model would be ready to go to production. Okay, so now you already have a reason to fine-tune. You want to start fine-tuning, but actually it's not an easy process. It's time-consuming, it's laborious, because first you need to select the pre-trained models. Second, you need to prepare a data set. Third, you need to choose the instance type that will best fit the training model. Then you need to define and configure the hyperparameters that will have a big impact on actually the impact and the results of the model. After you define these hyperparameters on initial phase, for sure you'll iterate on them. In parallel, you need to design evaluation metrics and scripts, and then you need to pack all the model artifacts in order to make it ready for deployment and production. So it's a time-consuming process. And it's a big heavy lifting that is not that differentiated. And that's why I am actually so excited to be here today. SageMaker AI manages the heavy lifting for you so you can focus on you bring as a true value proposition, which is your knowledge, the knowledge you have of your company, of your business, of your customers. And in the background, SageMaker AI manages the heavy lifting so you can actually bring what you bring better to the table, which is your differentiated data set and your knowledge. Let's see how you can do it on SageMaker AI. So when you use SageMaker AI, first, via Amazon SageMaker Jumpstart, you can have access to hundreds of pre-trained models. Then you can use, in order to go through SageMaker AI, you can use a graphic interface as SageMaker Studio, or if you want to do it programmatically via code, you can use Amazon SageMaker SDK. Also, you can create which models are discoverable within your organization, and this is key, right? Because we see customers that want to limit the models that their employees are accessing to. They want to limit per model family, per license type, so you can do it. And also, you can deploy it securely on a VPC with network isolation, which is key in case you have sensitive data or a sensitive environment. Now, considering that you already opened SageMaker AI, that you already chose the instances, that you're ready to start, you need to prepare your data. There are different ways in which you can prepare the data set that you are going to use in order to train the model. The first one I would like to tell you is domain adaptation. As the name says, basically you are giving more text, more information to augment the context so that the model becomes more relevant to your specific business or industry. For example, if you work on a legal company, you are going to onboard on the model legal docs, legal briefs, financial regulations that will allow the model to learn. And next time that fine-tuned model predicts a token, it will predict considering also this new data set that was not used to train the public available off-the-shelf models. Domain adaptation, you can configure your data in a quite easy format like text format. Another way is instruction fine-tuning. And I think the name is quite self-explanatory because you give instructions to the model. You teach the model how you expect the model to summarize a certain doc or how to follow a certain template that exists within your company. How do you do it? So you give to the model pairs of question, answer, question, answer. You teach the model how you expect the model to behave. And by doing this, you are fine-tuning the model towards a specific goal. In this case, you can deliver the information via JSON file. A third option is visual Q&A, which is actually what Sam today will bring in his demo. And here, instead of only having a text input-based approach, you have a multi-model approach. So on top of the text, you also have an image so that you give a new layer of context to the model. And now, before we move through the fine-tuning process, I want to address a misconception or a concern that customers have. Usually, customers come to us and they mention that, oh, I need hundreds, thousands, millions of data to fine-tune the model. Actually, we saw quite good results with hundreds of samples, even sometimes with less than 100. So what I would really encourage you is to start with the data set that you have, and you might be pleasantly surprised with the results that you will achieve. If you don't have a big enough data set to fine-tune the model, also an option that you can leverage is synthetically generate data. So what you do here is that you use a large model like Llama 3.1 405B. You ask that model to answer to questions or data annotations of your company. Then use a human team in order to vet the quality of those answers. And finally, you use that new data set that you created, that pair of question answers, to fine-tune a smaller model like Llama 3.18b that we see a lot of customers actually bringing into production. Now, you have already prepared your data, right? The new data set that you're going to use to customize the model is prepared. So let's actually understand the options you have on SageMaker to fine-tune the data. So the first option that you have is Amazon SageMaker Jumpstart. And here you already have access. So you already have access to pre-configured scripts, also to hyperparameters that are already previously defined. Naturally, you can adjust, but there are already some predefined hyperparameters. Also, you have access to data sets. So through a quite easy UI to use, you have many configurations already set up. If you want higher customization, if you want more control, you can use Amazon SageMaker training, which usually is used for large training jobs or hyperpods. And these two options, they are not exclusive, okay? So they are interchangeable. You can go with Amazon SageMaker Jumpstart, easier, faster to start, or you can use Amazon SageMaker training. After you fine-tune the models, SageMaker AI does the heavy lifting again for you. So basically, SageMaker AI packs the model artifacts and makes it quite easy to deploy into production and to put it behind an endpoint. And here you have two options. Actually, you can deploy your fine-tuned model via SageMaker, or I'm also quite excited to tell you that you can do it via Amazon Bedrock. So Amazon Bedrock is our fully managed service that offers access to hundreds of pre-trained models. We see many customers that actually are starting to use Bedrocks, and in particular Bedrock's workflows. So there is a feature in Amazon Bedrock called Custom Model Import, CMI, that allows you to bring your fine-tuned model from SageMaker to Bedrock, and then by using Invoke Model and Converse API, you can embed that fine-tuned model on your Bedrock workflows. We've gone through the process, we fine-tuned the model, and now we need to bring it to production. And this is a really important moment, because you need to choose where the inference will run. And it's really important because while you train your model periodically, when it goes into production, it can generate hundreds, thousands, or even millions of predictions per day. And that naturally has an impact in terms of costs. On AWS, we designed our own silicon. We push the envelope in terms of performance and price performance. And an option that you have to run your inference workloads is AWS Inferentia. AWS Inferentia 2, in particular, is able to deliver up to 4 times the throughput and 10 times lower latency than the first generation of Inferentia. Also, it has high-speed connectivity between the accelerators to allow for large-scale distributed inference, and is able to achieve a 40% better price performance when compared to comparable Amazon EC2 instances. So now we have gone through the process of fine-tuning, and it's actually time for us to see a demo. So please welcome Sam Sanders to the stage.
Thank you so much, Miguel. So now let's take a look at how to get started fine-tuning on Amazon SageMaker, specifically using SageMaker Jumpstart. Now, at the core of fine-tuning on SageMaker Jumpstart is the use of Amazon SageMaker training jobs. And a training job is comprised of one or more EC2 instances. Now, this can be CPU-based instances or GPU-based instances, or even accelerator-based instances such as Trainium. These EC2s will host a container that contains the algorithm script or container that will be used to fine-tune your data. Your data will reside in Amazon S3, as will those pre-trained model weights and biases. Now, once fine-tuning is completed, SageMaker will terminate these EC2s automatically and then save those fine-tuned model weights and biases back over to S3. Now, what SageMaker Jumpstart does is it encapsulates and abstracts a lot of these processes, allowing you to get started quickly. So, for example, it contains default predefined fine-tuning scripts, so you need not write these yourself. It provides a smart selection of hyperparameter values that you can use as is or customize. It gives you default fine-tuning datasets that you can use or use your own. And it even gives you default instance type recommendations, allowing you to get started quickly. And as Miguel mentioned, domain adaptation, instruction fine-tuning, visual question answering, so those fine-tuning approaches are all supported out of the box today with SageMaker Jumpstart. So from theory to practice, let's jump into 2 examples where I will show you how to get started using SageMaker Jumpstart. And there's 2 demos here, one of which you'll be using the SageMaker Studio UI, one of which you'll be using the SageMaker Python SDK, but both of which you'll be using SageMaker Jumpstart. So regardless of your selection, you can use Jumpstart to quick and easily fine-tune and deploy foundation models. And we'll be looking at that visual question answering use case that Miguel spoke about previously. And this is not an uncommon use case. Many organizations contain custom data, custom images, custom forms, either printed or handwritten, that fine-tuned or pre-trained models may not have seen the syntax of, or the form of, or the schema of. And so fine-tuning becomes a very powerful tool to increase the accuracy for that previously unseen data. And we'll be using a multimodal model here, so the Llama 3.2 vision model, which is an advanced visual-based model which goes beyond just text-based understanding and adds a whole visual element to it. So for example, on the screenshot on here, we may have an image like this where we're trying to locate the location of that company. So we may say with the image a prompt that says where is this company located, and we'd expect that fine-tuned foundation model to provide Chennai, so the location of that company. And this is an example image that we'll be using within our demo. So let's get started. So I've loaded up the SageMaker Studio UI here on a demo, and we'll walk through the UI use case first to show you how to begin fine-tuning with SageMaker Jumpstart on the SageMaker UI. And you can see on the left-hand side, there are several options which you can pick within Studio itself, and we'll begin with SageMaker Jumpstart. When we do this, we're presented with a whole suite of models for different providers, including both proprietary and open weight. We'll select the Meta family of models, and again, we're presented with a whole suite of models from the Meta family. In our use case here for visual Q&A, we'll look at the Llama 3.2 11 billion vision. But notice there's a larger and a smaller version, 11B and a 90B, but we're explicitly choosing the smaller version here, so the 11B. We have a model card, which gives us information about the intended use case, some of the hardware and software requirements, and in the top right-hand corner, there are options for train and deploy. So deploy will deploy the pre-trained as is, and train will allow us to customize and fine-tune with our data. So the first option on the next page is the location of our data. So we can specify that, or Jumpstart provides us with a default data set to get started quickly. Now this gives us a visual question answer, VQ&A, just 3,000 example data set examples, but again, we can provide our own data set as well if we so wish. And again, we can now select the hyperparameters. So Jumpstart provides us with a default smart selection, but we can customize these. So for example, we can customize the parameter-efficient fine-tuning technique, perf, such as LoRa, which allows us to fine-tune on a much smaller set of parameters, typically less than 1% of all the parameters in the model. We have a chat template, which allows us to provide a chat completion template for a more conversational use case. We have gradient checkpointing, which is a Boolean value, which allows us to save memory at the expense of a slower backwards pass. And we have one more example, BF16 mixed precision training, which allows us to decrease some of the hardware requirements or fine-tune in larger batch sizes by reducing the precision of some of the stored variables. Now, Jumpstart also gives us instance type recommendations that we can use or change. And then we specify the location of our data set in S3, where those fine-tuned model weights and biases will reside. We specify VPC information, encryption information, I information. We give the training job a name. Then we're presented with a EULA. And once we read and accept this, this kickstarts the fine-tuning job within your account. And that's it. Just one page on the SageMaker Studio UI, and you can customize a state-of-the-art foundation model with your specific data without writing a single line of code. And most of those values are already pre-populated and defaulted, so you can get started very quickly. But a lot of you will want to use code, Maybe that's your preference or you want to automate. So for the next example, I'm going to do exactly the same thing, but now I'm going to be using the SageMaker Python SDK, still using SageMaker Jumpstart with the same example, but now using the Python SDK. And once that's done, of course, we get information such as the logs and other information that we can use directly within Studio. So we can query, for example, those logs as they're streamed in real time. But we'll jump over now to that second example. And now we've loaded up the SageMaker Python SDK, and again, we'll do exactly that same example, but now using a few lines of Python code instead. And we'll begin by importing that exact same model as before, that Llama 3.2 11 billion model. We'll also import a similar document VQA dataset. Here we're importing it from Hugging Face, but we could import it from Jumpstart as well. We're doing it from Hugging Face here to show you how to reformat it in the way that Jumpstart expects with a few lines of Python code, but you could do exactly the same thing with the SageMaker Python default dataset, and it's already formatted for you. But if you have your own data, you can run a few lines of code to format it in that format that Jumpstart expects, and we'll be having it in that JSON lines format that Miguel spoke about previously. So we generate that here, and as you can see, we have a JSON lines here with file name, we have the prompt or the question, and we have the completion or the answer. So again, we're generating that with just a few lines of code, and we're going to pass this with the images, for example, this one here, with our data back over to S3 to do that fine-tuning step. But if we use Jumpstart for the data source, it will already be within that format. So we upload back over to S3, and then we can select the hyperparameters as we did before. So again, a lot of these are selected for us and defaulted, but if we want to customize, say do 5 epochs, so to pass through that data set 5 times, we can overwrite that here. And we even get a command to validate our selection of those hyperparameters. We then just call that SageMaker Jumpstart estimator, so using what we just called, so for example, the model ID, the model version, the EULA, the instance type, and the hyperparameters, and then we just call a .fit method, and that fine-tuning job takes place for us. So again, rather than just a few clicks, it's just a few lines of code, and we could do exactly the same thing through exactly the same model. Now we're going to go back over to the UI once more, because I want to show you how to deploy with the UI, but we could do the same thing via the SDK. So back over to the UI, we can click deploy, and again, we just get one page from which we can deploy our fine-tuned model. And we specify here an endpoint name, we specify an endpoint type and instance count. We can do more advanced information as well, such as different types of endpoints. We can do auto scaling, but this one page is all we need to get started with just a few clicks. And SageMaker Jumpstart will take care of that inference script, it will take care of those environment variable selections, and it will allow us to deploy that fine-tuned model very easily. We'll skip ahead a few moments here until it's in service, and then we can begin making calls to that model. So we're going to go back over to the SDK once more, because I have ready more than one model on which we're going to make calls and invocations. And we're going to test this with the validation dataset that we made just before. So here I'm passing the base 64 encoded image of our validation dataset, and I'm passing a prompt for inference for each of those requests. And that prompt just reads, read the text in the image carefully and answer as the question states and seen exactly in the image. And then we give information about what to do with a yes/no question, different types of information to make the response a bit less verbose within the answers to the fine-tuned model. So we'll pass that with a parameter for the question, and that will form our prompt that we're passing with the validation dataset to compare the results. And then we're passing a few parameters like temperature and top plea to control the randomness and diversity of our outputs. So we have 2 models deployed here. One is the fine-tuned Llama 3.2 11 billion. One is a pre-trained Llama 3.2 11 billion. And we're going to compare the results to both of those. One is fine-tuned, one is not. And we're going to compare with the ground truth, so the answer, for 5 examples. So let's dive in. So number 1, what is the name of the university? you can see on the top line here is University of California, San Diego. Now, the pre-trained response isn't able to answer that question and can't give us that information. However, the fine-tuned response gives us University of California, and so does the ground truth. The second example is to whom is this document sent? So we can see on this image, in that scruffy handwriting on the second line here, we can see it's to Paul. Now, the pre-trained gives us Paul, but other information that is incorrect, but the fine-tuned gives us just Paul, and that matches the ground truth of Paul. So a good start so far for the fine-tuned. Number 3 is, according to the budget request summary, what is the total amount of other expenses? And we've got a tabular format here, but you can see on the 4th line of this tabular image, the answer is in fact 975 on the 4th line on that image where the cursor is now. The pre-trained response gives us 975, but 3 other incorrect values, whereas the fine-tuned just gives us 975, and then the ground truth is in fact 975. The next one is, according to the nomination committee meeting, how many meetings has S. Banerjee attended? So here we've got another tabular format here. We've got a couple of tables on this image. It may not be clear from this table exactly how many meetings he's attended, but if we zoom in onto the screenshot and zoom into that table, we can see the answer is in fact 2. However, the pre-trained response gave us 2, but then repeated the question and then gave us 3. However, the fine-tuned gave us 2, and then the ground truth gave us 2. And then my favorite example here is what is the number of persons present for the Sustainability Committee meeting held on April 5th, 2012. And again, we can zoom in onto this image and we can see the answer is in fact 6. However, the pre-trained response for this decides to start counting between 1 and 13, so it isn't quite sure. But the fine-tuned gives us indeed 6, and the ground truth gives us 6. So this shows that, at least for this data, allowing us to fine-tune allowed us to significantly increase the accuracy of that fine-tuned model compared to the same pre-trained model without fine-tuning. And indeed, that fine-tuned model matched the ground truth for all of those examples, showing a good use case here for fine-tuning and increasing that accuracy. Also remember, at the start of the first demo, we chose that smaller 11 billion model rather than the larger 90 billion model. And we chose this because in our use case here for our demo, the 11 billion was sufficient when fine-tuned to match the ground truth for all of our examples. So that not only means that fine-tuning allowed us to increase the accuracy of our responses, but it also allowed us to deploy on a smaller model than we otherwise would, so that 11B versus the 90B, and allowed us to not only save costs as a result, but also allowed us to decrease latency and increase throughput. So again, fine-tuning allowed us here to pick a smaller model than we otherwise would to save costs and to reduce latency. And SageMaker Jumpstart allowed us to do this, to get started quickly with just a few clicks on the console or just a few API calls or a few lines of Python code. Now, from theory to practice to real-life example, I'm going to hand over now to my customer Mimecast, who are going to explain how they're using fine-tuning on Amazon SageMaker to allow their customers to respond and detect business email compromise and cybersecurity threats. So please welcome Felix Laumann.
Thank you, Dan. I call the foundation models of not only Amazon and all the foundation model providers in the world, I call them the hidden champions, because they have made our lives so easy and have just lifted immense pressure from us as data scientists, very often also from data labelers. So I call foundation models the hidden champions to protect against cyber attacks. First of all, a little bit about Mimecast, who we are. We are a cybersecurity company, has been predominantly focused on email security, but expanding now into human risk. So any entry point of a cyber threat into your organization, we want to protect you against. Globally, we have 42,000 customers with more than 26 million end users protected. The number I'm most proud about are the 7 billion signals we process every single day. What is a signal? A signal can be an email, can be something like a Slack message, like a team message, or anything that goes through your organization, that goes between two people, potentially someone external and someone internal to your organization. 7 billion signals every single day being processed by our servers. 2 billion alone of them are emails. We are a global company, around 15 offices with 2,000 employees. Let me first of all walk you through an architecture. What have we built on SageMaker AI? Where have we fine-tuned models? And what we have done then with those. I show you here an example of a very specific type of attack. We call it social engineering. And what is that? Very often you might get an email or you might get a phone call, an SMS, and it sounds quite friendly in the beginning. It sounds kind of, yeah, how are you doing? How can we help you? Might you be able to be interested, and so on and so on. But what actually is the intention of these attackers is that they slowly, very slowly build trust between you and the person, and then in the end attack, get your credentials, make you transferring money to an account that you should have never transferred to, or doing something else, maybe stealing your IP or something else. We call that business email compromise, and we have developed a solution on SageMaker AI with fine-tuning models that we call advanced business email compromise, or ABAC. So how does it work? First of all, an email comes into your organization, quite normal. There is something like a post office, which we call the mail transfer agent. And that mail transfer agent is really the delivery mechanism to get the email from anywhere, from any organization in the world, from any private person in the world, into your company. The mail transfer agent is really the delivery mechanism, like the post office, for letters. Then next, we send all of the emails to a central thread service. That thread service is really there to accumulate information and make a decision based on all of that together, whether it is a business email compromise attack or not. What we look first at is the cybergraph. The cybergraph is a massive network of any communication you have ever had between you and an email address. So when you have responded to an email 10 years ago, we know which email you have responded to, and we know exactly who you have received emails within those 10 years. It's a massive data bank. We have that for each of our 26 million users. We want to then look at what kind of phrases are in those emails. Is there maybe something that is a monetary value? Could you please transfer us $20,000? That might be suspicious. I've never talked to that person. Is there maybe some kind of sense of urgency that the sender wants to give you? Maybe they say, can you please transfer that ASAP? Can you please give me a phone call in 5 minutes? That is highly urgent. All of these things are phrases that might make the email a business email compromise attack, and we want to read them and we want to find out whether it is or not. With that information that we get from cybergraph, and that we get from the phrase extraction model, we accumulate it into the threat detection, into the threat service, and then send it finally to the threat detection. And the threat detection takes all of those information, all of those data points into account, and makes a final call, is it BZ or not? Those two models are fine-tuned language models that are hosted on SageMaker AI, and I will tell you later how we fine-tune them and how we host them. Once then we have a final determination, a final call, whether it is a business email compromise attack or not, we then go back into the mail transfer agent and say, stop it or deliver it. Is it harmful or is it safe? Next, where do our foundation models actually help? What is the key benefit of having them, and why do we even leverage them? For me, there are two hidden champions, or two factors which make them hidden champions. One is the threat discovery. So really, in the very beginning, when we started that exercise about a year ago, we are really thinking about how is a business email compromise attack even defined. Obviously, we have our internal intelligence team, and they have decades of experience, but we also just asked the foundation model, can you please give me an example what a typical business email compromise attack is? And what we have then done is really embedded those suggestions that we got by the foundation models. So we looked at something which is then very high dimensional, which lives in an abstract space, but it gives somewhat of information of what that typical BET attack looks like. And this is called an embedding. And we later on go in details. It's very high dimensional for lots of examples. There's normally a decoder that is actually generating that embedding. But yeah, I'm also here to answer later a lot more technical questions. But then what we do second is we measure the distance to the billions of emails that we have in our archive. So we first ask the FM, the foundation model, how does a typical BC attack look like? And then we do a semantic search and compare based on a cosine similarity distance, which is telling us how similar those emails are that we actually have received from our customers, and can we take all of that into our training data set. Second, we have used foundation models for data labeling. Foundation models have, as Sam and Miguel shown, massive potential. There are large models like the Llama 405 billion. There are even Anthropic, Claude 3.5 and 3.7 that we have utilized, and other really, really large models that have been trained on a massive, really, really massive amount of data and have hence a massive amount of background knowledge. So we have really then asked the foundation model, given an email, what would you say? Is it a business email compromise or is it a safe email? Gives you a basic example and gives you some input, and we then took as a second step the human review to validate that. Obviously, no single example should ever be labeled by a foundation model alone without human review. So we normally have a validation process where a human on a service called AWS Ground Truth looks at each email, clicks, yes, that's correct, no, that's wrong, please edit it. That is not how we wanted it. Good. How are those two processes used in our machine learning training pipeline? I call it the customized threat protections for billions of emails, because really we have at the very first step an ingestion of emails which are on a daily basis roughly 2 billion. And we don't process all of them, but the majority of them have potential harm in them, so we need to look at them very carefully one by one. What we do here is, as the second step, which I just explained on the previous slide, we look at threats that have foundation models, that were suggested by foundation models, and then label them. We are big fans of Anthropic. We have used Claude 3.7 lately. We have been using before Claude 3.5, have both shown us immense improvements in speed and are very highly accurate for our use case. Then after that, we show those emails on AWS Ground Truth and then let a human review it, our security experts internally in the company. Is it really a business email compromise attack, or is it a legitimate email, and we deliver it safely? As the next step, we took then all of that data that our security experts validated and reviewed to train a binary classification model. Is it BEC or is it not BEC? And we have here used a Dilbert model. So we have a dimensionality of the embedding that's roughly that's 768 dimensions. And then we have a classification head on top that are simply two outputs. Is it BEC, yes or no? And then lastly, we have obviously a live analysis tool in place. So every time we process an email, we see it, we measure the total number of detections every single day, every hour, every minute, and then also can really early spot anomalies in case our model predicts too many, or in case we see a really large cyber attack that we have protected against. As you can imagine, this is not a simple linear process. We go over it again and again and again. About every 3 to 4 weeks, we improve our models and have more data that makes them more accurate every time we integrate our new data sets. Next, let me go into a bit of details how exactly the fine-tuning works and what we did here. There's normally a text in the email, sounds very friendly very often, hi Sam, What we do then with it, we embed this email. And this is here a single vector because every token, which is roughly every word, is embedded. But then afterwards, obviously, we accumulate all of those token embeddings and then have a large matrix of a single email that has some numbers, and they really don't make much sense to us, but we learn from them. And that's really what happens here. We then change those vectors of numbers to learn the context. As you can imagine, when I say, hey Sam, please buy an Apple gift card for me, I have tomorrow a customer meeting, Sam might find suspicious. Normally Felix goes himself buying these gift cards. Or if I say, can you please buy 5 apples, I have friends over tomorrow for an apple an apple breakfast, then obviously apple has a very different meaning. And we want to learn that, we want to understand that. And then very, very last, we look at all of those embeddings and all of those matrix in the end and make a classification. Is it BEC or not? And then have the binary classification algorithm telling us whether we should deliver the email or whether we should stop it and protect the customer against it. Good. A bit of an overview, really the summary of what I've been speaking about is really a comparison where fine-tune is better to be used and where pre-trained models have massive advantage. And it really depends on use case. For us, Miguel has already mentioned it, we want to have extremely domain-specific and models with very high domain knowledge. So we have that vast amount of data that we have received from foundation models, from our security experts, and have really trained models that can do exactly that, but nothing else. But that's good enough for us. A pre-trained model, you want to exploit the vast knowledge that has been trained on because it has been trained on billions of text lines. For inference, we have very low cost for a domain-specific model because normally you can choose a much smaller model, whereas for a pre-trained model, you normally have billions of parameters, very often 400, 500, or even trillions, that then are much more expensive to run and normally also come with lower, with lower throughput and higher latency. Why it works, very briefly, transfer learning is a really foundational piece of fine-tuned models because we use and leverage all of the knowledge that comes from the pre-training and comes also from the data that we give it additionally. Whereas pre-trained model is really all about masked language modeling. You mask a word, you mask 2 or 3 words and try to teach it how to predict those words consequently. Lastly, a bit more on the inference chips that we use. Miguel has already mentioned that Inferentia has massive advantages, and that's exactly what we use here. We use an Inferentia 2 chip, has 2 neuron cores, both have on-chip memory, which makes them very, very fast to run large models on. As Miguel also mentioned, they're very, very strongly linked with neuron links, very high traffic between those two, and then they have dedicated engines. So there's a tensor engine, a vector engine, and other engines which really are meant to be executing a certain type of task, and which we here use to run very, very quick our emails. We use an inf2x large. That's the smallest type of inf2, but we really use that to horizontally scale. We have hundreds of instances running in parallel to process the large amount of emails that we get every day. And we get about 1,500 emails per minute. Still can be improved, we work on it, but at the moment it's roughly 1,500 per minute. Latency is also very low. A single email, which can be multiple back and forth conversations, is normally around 200 milliseconds where we get that. So now I hand over to Sam again, who will show you some educational material. Thank you.
Thank you, Felix. That was awesome. So let's wrap up with a few resources that you can use to take away to get started with what we've talked about today. And the first is a link to the SageMaker Jumpstart product detail page. Now this will list some of the foundation model offerings that we provide and a bit more information about each. To dive deep into some code examples, we have here the SageMaker example repository. So again, a bunch of code examples on here, including the one we used for the second demo today, fine-tuning an Llama 3.2 11 billion vision. So if you want to deploy this in your own account or any other example and follow along and get started, this is a good place to do so. And finally, we have a fine-tuned multi-modal blog, again, covering the Llama 3.2 models, but this walks through both the UI and the SDK, so both demos we did today. So if you want to follow along, get started, walk through at your own pace, then these are the examples to check out. So I'll leave you with these 3 examples to get started. To upskill, visit AWS Skill Builder, our online center, and explore over 600 free digital courses, hands-on labs, and role-based games to get started and upskill. And with that, we thank you so much. Please do scan this QR code. It do helps us out greatly with any feedback you have. We're going to be around for questions, so kind of at the back, just down there by the coffee machines. So for the next 20 minutes or so, if you have any questions, any ambiguity, or you just want to say hi, come up to us, we'll be happy to chat. But thank you so much. Please scan the QR code and have a good rest of the summit. Thank you.